Hello class. Today we are looking at section 9.2, applications of the Pythagorean theorem and the distance formula. When you talk about the Pythagorean theorem, it involves a right triangle. A right triangle, we know, has three sides, three interior angles that add up to 180 degrees. If I see that box, we know that means it is a 90-degree angle. Opposite of the angle is the longest side of a right triangle, which is called the hypotenuse. We know on the L part, those are the legs. You have special right triangles. You have that 30, 60, 90. You have the 45, 45, 90. And you also have a Pythagorean triple, which is something like a 3, 4, 5 triangle. So right triangles are very, very important in math. You will definitely see right triangles when you go into your higher math classes, when you start talking about trigonometry. And trigonometry is nothing but the measures of triangles. That's it. So when you think about the unit circles, you want to remember the Pythagorean theorem, the hypotenuse, and legs. You want to remember these things, because these are things that you will see when you get to your upper level math classes. Going on page, so I'm on page 659, looking at the definition of the hypotenuse, the Pythagorean theorem, and it talks about the two legs of a right triangle. The Pythagorean theorem formula is a squared plus b squared equals c squared. You may have also seen the variables x squared plus y squared equal r squared. So if you've seen those before, that also ties into that Pythagorean theorem formula. Your distance formula is on page 661, and that's a very important formula that you need to look at also. Now turn to page 663, and you're going to hear me using my calculator as we go over these problems. On page 663, we're going to look at number 17. So 17 says the length of two sides of a right triangle ABC shown in the diagram are given. Find the length of the third side. On 17, they gave me 6 feet. And then they gave me 8 feet. I don't know what C is. So when you think about Pythagorean theorem, it is a squared plus b squared equals c squared. And c represents the hypotenuse. Okay, because that's your largest number. That's your hypotenuse. So we already have A and B. We just got to find C. So simple math, just plug in and solve for C. Now to find our problem, to solve this problem, we're going to say 6 squared plus A squared equals C squared. Okay, so we're going to crunch some numbers on the calculator. I know that 6 times 6 is 36. And then 8 times 8 is 64, equals C squared. And then we add those two numbers up, we will get 100 equals C squared. Now then you take the square root of both sides. So C equals 10. And we're going to write out units, which is feet. Now we know we take the square root, we have two answers, plus or minus. But if we're finding a measurement, we're going to use the positive part answer because we're measuring something. So we're going to use that positive 10. But we do need to remember that when we take the square root of both sides, we have plus or minus in our answer. Very important that you remember that. But I just want to use the positive because we're doing a unit of measure. Let's look at number 20. So lock in that Pythagorean theorem. So for number 20, I have B equals 7 feet. And this time C equals 25 feet. Okay, so for this particular one, I do not know A. I still have to use my Pythagorean theorem in the same way that I see it. I do not know A, so I'm just going to write A squared. B is 7 squared And then my hypotenuse is 25 squared. Okay, so now from here we're going to crunch some numbers. I have a squared plus 49. And let's type in what's 25 squared. We know 25 squared is 625. Now we want to solve for a to the second. And I'm just solving an equation. I'm going to subtract 49 on both sides of the equal. 49's go to 0. And let's subtract that 625 minus 49. And I get a squared equal 576. Now we want to take the square root of both sides. So you have your square root button. And A equals 24. And write down my units, which is feet. So very important. So let's do that calculator practice so you can see how I typed everything in right quick. And my calculator's fancy, but you can find these keys on pretty much any of your calculators. You can find these keys. So just want to get it somewhere so I can see the problem a little bit. Okay, so the first part was I took the square root of 575. So to take square root of 575, you say second x squared, and then you say 576. And equal, and I get 24. And that's how you find it. Very easy. So you say second, hit that x squared button, and then you type in 576, enter. You hit enter at the bottom, and it'll get you to your answer, which is 24. Very easy on the calculator. All right? Calculator helps save a lot of time. So if you know how to use it, you're doing great. Look at number 24. A equals the square root of 11. B equals the square root of 38. And they're measured in feet. So we know that whatever my answer is, I want to keep it positive. Use the Pythagorean Theorem again. I'm going to say the square root of 11 squared plus the square root of 38 squared equal c squared. Okay, so make sure you see that before I go on. Now, right here, I need you to remember that in my index, it's a understood 2 there because we said square root. Square means 2. So the 2's go away. I'm left with just 11. Bring down your plus sign. Again, it's an understood 2 here. And then those go away. And you're going to type in 38. You're going to write 38. And it equals c squared. Add those two numbers up. So we have 11 plus 38 is 49. Equals c squared. Take the square root of both sides. So c equals 7 feet. Calculator practice. Okay. I want to type in the square root of 11 squared. So I'm going to do parentheses, second x squared button, and then type in 11. You must move the cursor to the right so that the root stops drawing. And then close parentheses, and then hit that x squared button and hit enter, and you get 11. And then you type in the square root of 38. Let's type that one in. So I'm going to say second x squared. Oh, let's go back. Parentheses, second x squared, 38. Move the cursor to the right so it doesn't follow you. Close the parentheses. And then another feature you can use is raise key because you can raise it to the second. So you can either raise it to the second and then you can do raise and then type in 2, or you can hit the x squared button. And then enter and you'll get just 38. So those are important. So that's how we got our answer 7. And we know 11 plus 38 equals 49. We have to find one number that I can multiply twice to get 49, and that number is 7. We're going to keep just the positive because we're doing a unit of measure. Look at number 29. And I'm going to use my distance formula, which is on page 661. So the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And a lot of times students say y sub 2 minus y sub 1, x of 2, x of 1. Okay, so either way is fine how you read it. The 1 and 2 is just to let me know I have 2 x's and I have 2 y's. And that's all. That's the only purpose for the 1 and 2 in my subscript. Just to let me know I have 2 x's and 2 y's. That's it. Okay, it's not to be squared or anything like that. So make sure you know that. Okay, look at number 29. It is so important that you label before you plug in. I have -7 and 12. And then -1 and 4. I'm going to label x1, y1, x2, and y2. So when you do distance formula, the labeling doesn't matter. When you get to certain math, it does matter how you label your x's and y's, okay? But for distance formula, it doesn't matter how you label. So I could have labeled this x2, y2, and then x1, y1. But I have to keep the 1's together and keep the 2's together. Okay, you can't mix the 1's and 2's. So that part you do have to keep the same. Now plug it into the distance formula. And again, you can just hit second x squared on your calculator and type everything in. It'll give you the answer. It's super easy. Okay, so we have x2, which is -1, minus sign, and then x1 is -7. Okay, and if you don't like the way that looks, we know 2 negatives make a positive. So you could have said -1 plus 7 and just got rid of the sign. Square it, bring down that plus sign, and then y2 is 4, minus my y1 is 12, and then you square that. Okay, now, really at this point, I can type it in. So let's practice that right quick. Let's see if we get it all, we can see it. Okay, so you may not be able to see the keys, but just listen to me and you'll get it. So I'm going to hit that second x squared button. So you know that what that button is on your calculator already. You must, on the TI, I have to do the negative sign, not the minus. So my negative sign is at the bottom of my calculator here. And you see you have your minus sign. So make sure you do the negative sign. Because if you don't do the right sign, it will not work. I'm going to say -1. Now the first sign says minus. And the first sign here says minus. And that sign says negative. And you see the difference on the calculator, how the minus sign is bigger than that negative sign. You'll know if you've done it right by it because the signs look different. I'm going to close the parentheses. Oh, well, we need to open some parentheses first, don't we? So I'm going to do second delete, and that'll open my parentheses up. So if you have a second delete button, you can do second delete, and that'll insert a parentheses when you miss it instead of starting over. Or just start over. Not a big deal. And then you square it. Plus sign, parentheses again, and it say 4, that's a minus sign, 12, close parentheses, and then you can square it. And my answer is 10. And that is the answer I have in the book, and this is the correct answer on my calculator. So take your time. Again, so important, so important. Make sure that right here you do a negative sign. Minus sign, negative sign, minus sign. If you don't do your signs right, it won't come out right. On the Casio that I recommended, it doesn't matter which button you hit, it'll still come out right. On your Texas Instruments, you must do the right signs or it won't come out correctly. But just play around with your calculator and see if it works, if it doesn't work. You'll know because it'll give you an error. Okay, let's keep moving on this problem. But I'm going to go ahead and work it out by hand. So to work it out by hand, I have the square root of -1 plus 7 squared plus, and then 4 minus 12 will give me negative 8 squared. Okay, just keep working until you get down to that one number. So I have 7 minus 1 is 6 squared plus, and I'm going to go ahead and just say negative 8 squared. I'm not going to clean it up just yet. Now, finish it out. I know 6 squared is 36. Bring down your plus sign. I know negative 8 squared is 64. Add those numbers. I get the square root of 100, and we know square root of 100 is 10. So you can type it in or you can work it out by hand, but you'll get the right answer either way you go with it. So very important to see which route you want to do it. Okay, now let's look at number 33. And just going back and reading the directions. It says find the distance between the given points. And we know a point is a ordered pair. We know x comes first and your y comes second. So you just remember everything about the rectangular coordinate system, about ordered pairs. And that's all it is, they're just points. Find the distance between the given points. If an answer is not exact, use a calculator or give an approximation to the nearest tenth. We know nearest tenth is 1 decimal place. Let's look at 33. So for 33, we have negative 3 and 5, negative 5 and negative 5. I do want to label x1, y1, x2, y2. Now plug it into the distance formula. And we know what distance means. It's just telling me how long something is. So from these 2 points, they want to know how long is this point to that point. What's the distance? Now, some of us count steps, so we can count steps and look at things like that and figure out distance by just using our feet and just doing so many steps. We can figure out a distance very easily, or use a ruler, tape measure, things like that to figure out a distance. Now, the distance formula is really great when you have your distance at an angle. So when your distance is at an angle, distance formula works very well. If it's a distance that's horizontal vertical, you can basically just do so many steps and see what the distance is. But when it's at an angle, you use distance formula. This formula helps a lot. But you use distance formula on any situation, but it's just a really good formula to help you figure out how far something is. Very good for that. So right here, we're going to plug in. I have negative 5. Now, we have negative times another negative makes a positive 3. I'm going to go ahead and simplify that. A negative here times a negative there makes a positive 3. Plus y squared is negative 5. Minus my y1 is positive 5. And then I'm going to square that because that's in my formula. Again, I can type this in my calculator and be finished, or we can work it out by hand. Let's work this one out by hand also. Let's work it out by hand. Right here, I have negative 5 plus 3 is negative 2 squared, plus negative 5 minus 5 is negative 10 squared. Negative 2 times negative 2 is 4. Negative 10 times negative 10 is 100. Then we have 100 plus 4 is 104. And then we want to take the square root of 104. So you're going to say second x squared 104. And it's going to give me 10.1983803903. But they said round to the nearest hundredths place, to the nearest tenth place. So that's 1 decimal place. Right here, it says 10.19. So we know that if the second number is 5 or greater, we want to round that number up 1. So my answer is 10.19. 10.2, approximately equal to 10.2. Because originally we had 10.19, so we know to round to make that number 1 become 2. Okay, so that's it for section 9.2. Very easy to use, very easy to use your calculator. So definitely practice on the calculator if you have one. And we talked about 2 formulas. We talked about Pythagorean Theorem, and we talked about distance formula. So make sure you read those formulas very carefully and you understand how to plug everything into the right place.